Hello, and welcome to the video today for section 3.1, solving quadratic equations by graphing and using square roots. So to start off here, we're going to talk about real solutions. As we progress through this chapter, we'll get into other types of solutions, but right now we're only dealing with real solutions. All right, it is possible to have 2, 1, or 0 real solutions in a quadratic equation. We'll go through and realize how we can get these different types of solutions. Solutions can also be called x-intercepts, roots, and zeros of the quadratic equation. Solutions, roots, and zeros will be written as x equals. X-intercepts will be written as the point, the x-intercept, comma, 0. Okay, so there's a couple different ways we can solve these by graphing. The first one is if you want to use the graphing calculator. You don't have to, it's just one way to do it. Our first step here is to get the equation in standard form and enter in y equals. This is for a TI-83 or newer graphing calculator. The second step here is to press window. This should be your window that comes up. If this is not the window that comes up, you're going to press zoom and then go down to standard, and then this should be the window that will show up for you. Our third step here is going to press the second button and then the trace button. Okay, and we're going to go down to number 2, which is 0. All right, you can see here that it's highlighted. When you press the second trace button, it will say calc above it, so you're going to calculate one of these things. You'll then have a blinking cursor that'll pop up. It looks like a little X, or sometimes you can call it like a spider. So when you go through here, when it says right bound, all right, oh, this should probably say left bound first. So when you press left bound, you want it to be on the left side of the x-intercept. So if we're talking about this x-intercept right here, the first time, we want it to be left bound. When you're to the left of the x-intercept, you're going to press enter. Okay. When it says right bound, you're going to be to the right of the x-intercept, then press enter. All right, and then it's going to pop up a third time that says guess. You can just press enter a third time. Okay, and by third time I mean you're going to press it for left bound, right bound, and then you can just press it again to be able to get it. Now what will happen here, you notice that it'll come up at the bottom here and it will tell you the 0. The 0 is x equals -2. So x equals -2, we could call it as a 0. It's also called a solution, and it's also called a root. That's how we would write it if we wanted one of these three things. If they asked you, what is this? What are the x-intercepts? If it's an x-intercept, we would have to say the point -2, comma 0. So understand the difference here. Solutions, root, or 0 is going to be x equals. If it's an x-intercept, it's going to be written as an x-intercept point, which is the number, comma 0. All right, so that's how we would graph it using our graphing calculator. The next way we could do it is by using Desmos, okay? Truthfully, I think this will probably be the easier way, but you can use whatever way you'd like, all right? It's good to also familiarize yourself with the graphing calculator, so in the future you know how to use it as well. All right, so our first step is to get it into standard form. Just a reminder that standard form is ax squared plus bx plus c, okay? F of x and y are interchangeable. All right, so once we get into that form, all right, we're going to type the equation into Desmos as either y equals the equation or the equation equals y. It does not matter which way you write it. The graph will show up, and you're going to click the intersection of the parabola and the x-axis, all right, to be given the x-intercepts. Notice I clicked on these 2 points. They popped up. These are the solutions to the quadratic. So -2, 0 and 3, 0 are x-intercepts. Okay, those are the x-intercepts of our graph. All right, so that's all you have to do. All right, at the bottom, just a refresher as well, as you can kind of see here, -2, 0 and 3, 0 are x-intercepts. If we wrote it as x equals -2 and x equals 3, they are roots. And I'm going to get rid of or, and it should say solutions or zeros of the quadratic equation, okay? So those are just the different ways we can write it. So those are a couple ways that we can solve these by graphing. When they ask us to graph these things, we're looking for the x-intercepts, all right? And we can call them obviously a couple different ways. All right, the last thing we're going to cover today is solving by using square roots, all right? Using square roots should be used to solve when we do not have a bx term, right? We do not want a bx term here because then we'll be able to do it. Or we can get the quantity that's being squared by itself. That's going to kind of be more like, for example, 3. No bx term is kind of like for examples 1 and 2. All right, so our goal here when we go to solve using square roots, you notice we have an ax squared term, we have a constant here, but we don't have a bx term. All right, our goal to be able to solve this is to get the x squared by itself. To do that, our first step would be to add 31 to each side. So we'd have 4x squared equals 80. We need to get the x squared by itself. So we divide everything by 4. And we get x squared equals 20. All right, in order to undo a square, we need to take a square root. Whenever we take a square root, we need to make sure we have 2 solutions here because it can either be the positive version or the negative version. Okay, and we have the square root of 20. All right, we do need to simplify all radicals. So our answer here, if we wanted to simplify it, 20 could be simplified to the square root of 4 times the square root of 5. So our solutions would be x equals plus or minus 2 times the square root of 5. If they ask you to estimate that, you could obviously type that value in your calculator, all right, and then it would probably tell you how many decimal places to round to. Please understand, the way you could check this is if you get the same answer as a square root of 20 as the same answer as 2 square root 5. All right, so this is our solution to number 1. Okay, our goal is going to be the same thing for the second problem. We're going to try to get the x squared by itself. We divide everything by 3, so we should get x squared equals -3. To undo a square, we are going to take the square root of each side. All right, so that will leave us with x equals plus or minus the square root of -3. As of right now, anytime we take the square root of a negative, we would say no real solution. All right, and that's because we can't take the square root of a negative number. All right, in later sections in this chapter, we are going to find out about something we call imaginary numbers. All right, but as of right now, we haven't done that. So whenever they ask you to and you get x equals the square root of a number, we're going to say that there's no real solution because we can't take square roots of negatives. All right, our last example here is going to be 2/5 times x plus 3 squared equals 5. All right, so our goal here, like I said in the first part, when we go through it, our goal is to get the quantity that's being squared by itself. So in this case down here for number 3, we're trying to get the x plus 3 squared by itself. Our first step here would be to multiply by the reciprocal. So we'd multiply each side by 5 over 2. Those would cancel out. We'd have x plus 3 squared equals 25 over 2. Okay. And now what we would need to do here is the quantity that's being squared is by itself. So now we can take the square root of each side. So we would now say x plus 3 equals plus or minus the square root of, let me write this as one big thing, 25 over 2. Okay, a couple things we can talk about here is we can actually really rewrite this as the square root of 25 over the square root of 2. That's our rules of radicals. Okay, and the nice part about this is we know the square root of 25 is 5. All right, and down here we notice that we still have something mathematically we're not allowed to, and have a radical in the denominator. So to rationalize the denominator, we would multiply by the square root of 2 over the square root of 2, which would give us 5 square roots of 2 over the square root of 4. Right, I'm showing you this step. You'll realize something in a second. So this 5 over the square root of 2 with the denominator rationalized is 5 square roots 2 over 2. Okay, so we're now going to have x plus 3 equals plus or minus, I'm going to put this thing back up here, 5 square roots 2 over 2. All right, and we want to get our x by itself, so we subtract the 3. Put that in front. So our answer is x equals negative 3 plus or minus 5 square root 2 over 2. All right, those would be our solutions, roots, or zeros of the quadratic function. Okay, so understand if you get the rationalize the denominator here, you wouldn't need to write this step. That's why we rationalize the denominator. It will always just come out as 2. Okay. Thank you so much. If you guys have any questions, please let us know. Your homework will be posted. Have a great day.